Good morning, everyone. Coming up next, we have Tommy Say to share building scalable and efficient AI platforms on Kubernetes and GKE. Let's give him a big hand.
Hello, everyone. Thank you for attending this session together. So I'm a customer solution architect from Google Cloud. So my day-to-day is just to help our customers to build cloud-native applications and running on the cloud. So Kubernetes is one of my specialization. So I'm going to share a bit more about this technology today in this session. So first of all, how many of you are using Kubernetes today? Anyone? Oh, good. A few people using, great, yeah. For those who not familiar, maybe a little bit advanced to you, but doesn't really matter. I think the key takeaway today is around the concepts. And of course, we got like a tutorial and things you can try out at the end. I've got like 2 QR codes you can scan later on. Okay, so for those who are familiar with Kubernetes, or even for those who don't, the project was released as a 1.0 version 10 years ago, exactly. So it's today, as in back in June the 6th, is the 10th anniversary of Kubernetes. So a lot of people in the community celebrate that. According to CNCF, over the past 10 years, around 314,000 of code commits to the open source Kubernetes project. And that's over by like 74,000 contributors. And the number of organizations grew from just one from Google, because we open sourced that like 10 years ago, to over 7,800 organizations. Okay, so this topic also around AI. So, I mean, Gen AI is everywhere since last year. And there are many companies, including Google, we're building and delivering new foundation models, for example, like Gemini, or even we have an open model called Gemma. So some people, they want to adapt models, either to fine tune or doing like retrieval augmented generation from their own private data. And also there are many people just want just a simple API that they can consume this large Gen AI model for their applications. So in the AI community, there are many open models, and you probably heard about Llama, or even we have Gemma from Google. So they are like evolving rapidly in terms of the performance and also the quality. So it's getting better day by day. And it also further enabling innovation in terms of the techniques, for example, like flexible deployment, task or domain-specific fine-tuning, or even resource optimization. So you can imagine those large models, they take and consume a lot of compute resources. So I mentioned Gemma, just a quick worth to mention here. We just released Gemma version 2 just a few weeks ago as our latest open model. So even today, you can deploy Gemma on Kubernetes, of course, on our managed version of Google Kubernetes Engine, GKE. So there are many different challenges when it comes to working with large models. First of all, you want to optimize the price, the performance, as well as not compromising the quality, and running that at scale. And large-scale training with GPU is always a problem since last year. There's a lot of limited supply in terms of the capacity. And thirdly, typically we see that many customers, when they run the AI platform, they also have different teams of AI engineers. And you can imagine a lot of people sharing the same limited capacity. That could be quite a huge problem. So multi-tenancy efficiency is another problem to solve here. So Kubernetes actually can provide a really good foundation for working with AI workloads. So its flexibility in terms of the number of frameworks, you can see that in the ecosystem, in the open source world, there's so many you can pick from, like TensorFlow or PyTorch, and even Ray. And they are really portable, as in everything runs as a container. So you can just run wherever you like. And the performance of having Kubernetes is really important, as you need the orchestration, the automation for even like AI accelerator like the GPUs, or even at Google we have the TPUs. And thirdly, the efficiency as well. Since the automation within Kubernetes, it enables you to run a really cost-efficient infrastructure and just scale all the resources when you need that. So maybe you probably don't know, there's over 70% of the innovative Gen AI companies are running on Google Cloud. So maybe you recognize like Anthropic. They're actually the maker of the Claude model, and they're using Google Kubernetes engine and also GPUs and TPUs on our platform to do all this. And Runaway is just another customer that they do like text to video kind of AI platform. They also using Kubernetes. And also they use like GKE to orchestrate thousands of like H100 GPU. So this is just give you some a few some examples like what are the other like major AI players in the community are doing. And Kubernetes, of course, is not just limited for AI workload. For those who have been using it, you probably deploy your web service, your APIs. Even you can deploy database and run batch jobs with Kubernetes. So when Kubernetes integrated with Google Cloud as a managed service, it's called GKE, as I mentioned, you get a much easier day-to operation experience in terms of like upgrade and security hardening, and that we all do it for you. So when you take GKE as a unified AI platform for the AI sort of use case, you can take advantage of our specialized AI accelerator like GPUs or TPUs, and also the high bandwidth network and storage infrastructure. So we have made a lot of enhancements on the Kubernetes stack. So I will just go deeper a little bit in a moment on Q. Q is a Kubernetes native job queuing API and controller that we've been working on. And together, there's a bunch of libraries and tools and the frameworks that you can work on top of Kubernetes, like TensorFlow, PyTorch, or JAX, or Ray, to train and deploy your AI workloads. So this is just some the existing choices that you can have on Google Cloud, as in the GPUs like A100, H100 you can use, or even the TPUs. So for the TPUs, we also use that to train our own models like Gemini and Gemma. And just a bit of history of the TPU, probably you might not be aware of. We've been doing this since 2018. And also TPU, in case you do not know, is called Tensor Processing Unit. So it's a specialized kind of hardware to do tensor or multi-dimensional matrix calculations. And we've been using that to support our services like Search, YouTube, Google Translate, and Gmail, etc. And also we provide this for our cloud customer to use it. And the latest version we announced early this year is called Trillium. It's the latest generation of TPU. So there's more performance and more bandwidth comparing to the previous version. So, okay, so now go into the more interesting part. Some of the open source technology that we designed, we implemented in Kubernetes recently to enable efficient job scheduling, management, and also to give you the powerful distributed computing capabilities. So for those who use Kubernetes, you might be aware of the job API. So the job API it was quite limited at the beginning of the design, also cron job as well. So it's just for like running batch jobs on Kubernetes, basically. But there's a key limitation in that is that you cannot have like a job definition with different pod templates. So pod, in case you do not know, is a basic, the most fundamental unit of compute that you deploy on Kubernetes. So there are also other alternative APIs apart from job. You can maybe, there's an open source project called Kubeflow that supports like PyTorch or TensorFlow job processing, and also KubeRay is a Kubernetes integrated RAID kind of controller and APIs for running RAID-based jobs. And also, of course, the common one you might be aware is the stateful set. So when you want to do complex batch job processing, like you want a job with multiple different pod templates, you can do that today with Kubeflow, for example, like PyTorch job here. So you can see that you can get a master job template and a worker, so they can do different things here. So recently, there's a new API in Kubernetes called JobSet. It enables you to do something more similar like what Kubeflow could do, but it's just more Kubernetes native from its own. So in this example, that you can have a driver, like a master kind of pod, and then it would just coordinate with some workers there. So currently it's in alpha. It's a version 0.5, 0.2 for now. So I mentioned Ray. Ray has become a really popular open source Python native distributed computer framework, and it's got the primitives to easily parallelize, like scale AI workloads just from your laptop to the cloud, without the need of building like complex compute infrastructure. So what Ray makes up of is just there's a list of high-level libraries that enable you to scale your AI workloads. And then at the core itself, it's just a distributed computing framework that it can be deployed on different cloud providers and also on Kubernetes. So on the AI libraries from the Ray open source project, it supports like data pre-processing and training, tuning, and serving the AI model. So it got integration with some familiar frameworks, like I mentioned, like TensorFlow or PyTorch or even Hugging Face. And remember that data scientists and machine learning engineers, they are not really infrastructure kind of people. So it's always a challenge for data scientists or ML engineers to think about how they scale the model in a production environment, but Ray as a framework that can help in that addressing that challenge. So this is a reference architecture of running Ray on GKE. So it's a bit similar to the earlier diagram I showed to you. So for a unified platform, it's difficult to have like multiple users. So as I mentioned, you got like data scientists or ML engineers might be working on the same platform. So you can imagine when they all work together, they're always like competing for resources on this platform, and like running many batch jobs or training jobs at the same time. So Q is the new set of Kubernetes API and controllers that I just mentioned that will help in job scheduling and job management. So this how Q works is it will emit jobs when there's enough compute resources in the cluster. So it works with the standard Kubernetes job or job set that I mentioned earlier, the Kubeflow jobs, and also RAID job. And it supports different flavor of resources. There's a concept of flavor in Kube that you can say, okay, this is a flavor of standard compute and some spot preamble compute, and then you can have another flavor like a GPU or TPU, so that you can prioritize like your jobs to run with all these different kind of resources. So it's in beta already. It's the latest version I checked last week is 0.7. So there's also a concept called GAN scheduling. Not sure if you heard about it. Especially, it's really important when doing model training. As in, you want to parallelize your training at a company. So you don't want like, okay, for example, I want like 10 GPU get one in the next minute, right? So I don't want like that GPU sitting here and not doing nothing, because I need all 10 GPUs to start at the same time for that job to run. So it's a bit tricky in terms of it's about auto-scaling environment. So the VMs come and go away. And also remember, cloud is not like infinite resource. It has quota, it has capacity. So, and also typically like system admin, they want to limit or set quota for the resources. So they don't want like somebody just take, to get all the resources, but no one else gets. It's more the fair sharing. This is a bit of a details how queues work, as in the definition. So basically, there's a concept called queue within queue. So the name is a bit similar, but basically what it does is within the cluster, you define like different queues. So maybe team A get a queue for team A, and team B may get their own queue as well. So in this example, I can set a queue, have a quota of 50 CPU and 200 gig of RAMs. So what queue does is it will do the quota check when someone submits to that queue, and if there's enough quota, you will just let it to run. If it doesn't, then of course it will just pause the job there. And also there's a preamble feature there. I will just show you maybe a quick demo if I have time for that. And so how do you add a job to a queue? In Kubernetes, in this example, it's just a plain job definition. So you just add a label, like this one is xks.io/queue name. So the name of the queue is called job queue, and as simple as that. And you mark it as a suspend at the beginning so that it doesn't run right away, and let queue to toggle that status of the job. And for more advanced setup, you can have ambition check for that. So I mentioned the queue does the coder check at the beginning, but if you got some ambition check after the coder check, for example, there's also one thing many users or even our customers very confused is that on the cloud, quota doesn't mean capacity. Say I give you 100 of GPUs, doesn't mean that you can get all those with like that sort of capacity. So there's also, it's a good practice to have an ambition check to make sure that apart from the quota that you set on the user side, the provider actually does have the capacity. So, so this is very important when it comes to AI job, as in model training. And there's another concept called cohort in queue. So I said that each team can get like a cohort in queue. So I said that each team can get like a queue to run their jobs. So this example is team A, they get a standard queue. So those compute capacity can be reserved in advance. And also there's a best effort or preamble kind of queue there. So if they, like say team A want to run a bit more, but without the reserve capacity, then the best effort queue can take care of that. And so you can add like different queues, like even across team A and team B. And if for any reason that team B are not using some of the reserve capacity, team A can sort of borrow the capacity from the other team just to make sure the jobs can be run without like letting the compute resources like sitting there not doing anything. So this is quite a common challenge we heard from our customers, or maybe you might have heard in the community. It's like why I can't get some GPUs since last year, or when can I get the H100 from NVIDIA, or I just only like this GPUs to run for a week. Is an industry-wide capacity challenge. So in Google Cloud, we got a thing called Dynamic Work Scheduler, or DWS. So it helps you to obtain, say, I gave the example of 10 GPUs earlier, right? So I want to be that DWS to, okay, just get me that 10 GPUs as soon as you can, then just run the job for me. And I don't want like just 1 or 2 GPU get obtained piece by piece, and my job just, I don't know whether I can run the job or not. So DWS takes care of that. And also we get a calendar mode. It's more good for like retraining or fine tuning. Say maybe I just want to do that retraining once a month, and just a bit of assurance of the timing. So in the Kubernetes side, we also propose a new API called provision request in the cluster autoscaler. So it's more to ensure the resources for a given set of pods can be run all or nothing. So today, if you want to say I run 10 pods at the same time, the cluster autoscaler will just randomly just try to like look at the kube scheduler, just try to run some pods, maybe not 10 at once, but when it comes to AI training, it's very important that I want all the resources at the same time. So provision request is just an enhancement to the cluster autoscaler to enable that. So this is one example that I want to run 4 pods with this request sent to the cluster autoscaler. And we got an integration with our DWS, if one of the specific implementation called kube provisioning, GKE.io, that one. Okay, so yeah, that's quite a lot talking already, but maybe let me just do a quick demo, just to see. Hopefully I have enough time. Yeah, just switch over to this. Okay, so I will just do 2 demos at once. So I mentioned kube around the cohort earlier. So I've got the Kubernetes clusters here. It's called MLGK. It's got different nodes here on Google Cloud. And so I deployed the kube RAID operator and the kube controller here. So I'm going to run 2 demos. So one is related to kube, one is the other one is on kube RAID. Right. So I've got a job here. This is a job that needs 2 pods because parallelism 2. I want to send to the kube called tenant B spot. So it's a preemptible kube, and that's it. Maybe I'll just stand there. Okay, so after I send this job to the kube, yeah, it's a good cheat sheet. Yeah, I just don't want to type too much. You can see the job is run on these 2 reserved nodes, and yeah, you can see this job get emitted by the kube, and yeah, that's it. And then I want to run, say this is team B, they're using a preemptible kube, and over the resolved compute capacity, and then I got a team A, I got a high priority job to run. So when I submit the team A job, it will just kick the team B job away from the cluster. Okay, so maybe I'll just check the jobs again. Sorry. Yeah. So you can see the spot job gets suspended by Cube, and then the higher priority job get run here. And then if I just check the pod again, so you only see the higher priority job here, but the preemptible one just gone. And then if I say, let me just remove the high priority one and see what happens. So after doing that, so you see the spot pod from team B just get resumed again. So as simple as that, that's what Cube is doing. And then another demo I can show you right now is to do the DWS integration with Cube. Right. So this is what the second demo is doing. So I just need like 3 GPUs to run for that job. And Q knows about it, so you will create the provision request with the cluster autoscaler. And then the CA, the autoscaler will try to obtain the GPUs for me from DWS. So this is what is doing right now. So once it's ready, those 3 GPUs are available, and the CA will just spin up and attach those VM, the nodes, to the cluster. And then Q will just start the job from suspend. So when the job completes, which is good, that is what I want, then just finish the job. I mean, it's just complete. And when the VMs are no longer needed, the autoscaler will just remove those nodes for me. And as simple as that. Actually, I got a third demo. I can show you very quickly how to use Ray to do an inference of a model using GPU as an acceleration as well. Maybe I think just do it quickly before I end the session, and also to show you the result from the second demo, hopefully. Okay, so I've got a text summarizer model inference running with Ray on my GKE cluster. So this is a text summarizer. It's called Ray service. And I just need to get an endpoint for that. And this I've got a Python script here. This one, it's just saying, it's just a text saying the French capital Paris with some statistics. I just want to have a summary of that in a shorter sentence. So I'll just send this script to that inference endpoint and see what happens. Yeah, so it does a summarization for me instead of a longer sort of text. And if I just expose, yeah, so I've got time. So the job APIs have been enhanced a lot throughout the previous years in Kubernetes. So it also supports job suspend and failure handling. It's much better. So if it's something a simple batch job, you can just use that. If it's something more complex like what I showed, like multiple different templates and things like that, so you can consider job set or rate job. And if you got like many batch jobs, like in the other one of the demo I'll show you, and then you require different kind of resources, and then Cube is a good way to manage that execution. And then if you got problem with GPU obtainability, then DWS on Google Cloud will help you. All right, so hopefully it gives you some idea what's happening in the AI community. And yeah, so this is the 2 QR codes you can scan. This is the very last slide here. So if you want to learn a bit more what I explained, scan those 2 QR codes. Basically, just some resources and documentation you can read. And also on the GitHub repo, there's some demos you can try out. Yeah. So yeah, that's it. Thank you, everyone.
Because in the whole open source conference, I think it is only the session about talking about the Kubernetes. And then if you want to learn more Kubernetes, we have the discount code for you from the Linux Foundation. You can scan another one. You can get the 20% discount on the Linux Foundation the training. Wait a minute. Yes. This is only discount for this event. So you can try that. Yeah, you can take the picture first and then use the discount code. Then it's okay. Okay, it's extra the information for you. Okay, that's all. Any question for this session?
If you got any questions, you can. Yeah, if you still got anything you want to discuss related to Kubernetes, feel free to grab me. I will be still around for the next hour. So yeah, thank you again.